kids, Miss Kulkarni here. In this video, let's continue with chemical reactions and we will talk about single and double replacement reactions. So let's begin. First of all, what do we mean by a single replacement reaction? It is a reaction in which one element replaces the other element from a compound. In other words, this can be like a love triangle or a breakup. Alright, let's take our first example. A piece of zinc is added to a solution of silver nitrate. Those are our reactants. So zinc is Zn, it's solid because it's metal, and silver nitrate is AgNO3. It's given to us as solution, so it's aqueous. And how do we find out the products now? This is a single replacement reaction. So zinc is going to replace silver. So we form zinc nitrate. That's the formula for zinc nitrate. And silver will be the lonely element now. Let's work on balancing the reaction now. So this is what we have on both reactants and product side with the number of atoms before we balance. If you look carefully, nitrate is 2 on the product side, whereas we only have 1 nitrate on reactant side. So when we make that 2, we need to go back and change the coefficient for silver nitrate as 2. When we do that, silver will have 2 atoms now. And we need to make sure we change number of atoms to product side. So that makes silver atoms 2. And we got a balanced reaction. Now let's figure out if the reaction is a redox reaction or not. The charge on zinc will be 0 because it's the element by itself. Same will be for silver metal. It will be 0 as the charge. And if you look at silver nitrate, the charge on silver in the compound will be positive 1. Same way for zinc nitrate, the charge will be positive 2. So zinc changes the charge from 0 to plus 2 and Ag silver changes the charge from plus 1 to 0. So the charge on zinc is going up, it's increasing. That means it will be oxidation. And for silver, charge is getting reduced. So it will be a reduction reaction. So yes, this will be a redox reaction. Let's work on the second example. Let's begin by listing the reactants. Lithium, it's solid because it's metal. And then we got barium hydroxide. It's solution, so it will be aqueous. And when they react, lithium is going to replace barium. So we end up having lithium hydroxide and barium will be the lonely single element now. Now what will be the state for lithium hydroxide? Using solubility chart, we can predict it will be aqueous because it's group 1 element lithium and all salts from group 1 elements will be soluble. And barium is a metal, so it will be solid. The next step is balancing. And this is what we have before the reaction is balanced. So let's make the atoms equal. If you want to make hydroxide equal to, then we need to go back and change the coefficients for lithium hydroxide as 2. With that, the lithium ions also become 2. So then we come back to the reactant side and make that as 2. And then look at this. The reaction is balanced. Will this be a redox reaction? Let's find out. The charges on lithium and barium will be 0. And in compounds, barium will be positive 2. Lithium will be positive 1. So lithium changes the charge from 0 to plus 1. It's going up. So it's oxidation. And barium reduces the charge from positive 2 to 0. So that's getting reduced. So overall, the reaction will be a redox reaction. Let's move on to the next problem. fluorine gas is bubbled through, that means it's reacting with solution of strontium bromide. Let's list the reactants and products. So there you go. We got our reactants ready, and now strontium is going to pair with fluorine. So we get strontium fluoride and bromine. And look at this. The number of atoms for all the elements is exactly same on both reactants and product side. So I guess the reaction is already balanced. Will this be a redox reaction? What do you think? I guess the earlier single replacement reactions were redox reactions. So this could be a redox reaction. But let's find out ourselves. The charge on fluorine and bromine is 0, and the charge of bromine in the compound is -1 and fluorine has -1. So you can clearly see the charges are changing for fluorine and bromine. That means this will be a redox reaction. Now let's work on one more reaction of single replacement. Sodium is added to water. Sodium is metal, Na, so we put solid, and water is H2O, but it helps if you write water as HOH, as if hydrogen is combined with hydroxide ion. And this will be a single replacement reaction. Sodium is going to replace hydrogen. So guess what we get? We end up getting sodium hydroxide, and the hydrogen will be the lonely element, but that is a diatomic, so it's going to be H2. The state will be gas for hydrogen, and sodium hydroxide will be aqueous because sodium belongs to group number 1. How about balancing this? Look at this. These are the number of atoms for all the elements. Hydrogen is the only one which is not cooperating, so let's make that 2. If you want to make that 2, we have to change the coefficient for water as 2H. And with that, hydroxide becomes 2. Then we go back to the product side and make that as 2. So we have to change sodium also as NaOH. When sodium changes to 2, we go back and we also change the sodium coefficient as 2. So that's a balanced reaction. Now will this be a redox reaction? I think it's going to be a redox reaction. And how do we confirm that? Sodium by itself will have a 0 as the charge, whereas in the compound it will be +1. Hydrogen will be +1 in H2O, whereas hydrogen by itself will be 0. So that confirms that this will be a redox reaction. Let's switch to double replacement reactions now. Now what exactly we mean by double replacement? The cations and anions of two different compounds, they switch places and they make entirely two new different compounds. That's what it is. So in a way, you can compare this with wipe swap. The partners are getting exchanged. So AX and BY are two compounds and they change the partners. So A gets together with Y and B gets together with X. Now remember, double replacement reactions could be also subdivided into two different types. One of them is neutralization. What is this? This is an acid-base reaction. When they react, the hydrogen from acid combines with hydroxide from base. And the products are always ionic salt and water. Also, the pH for the final products will be neutral, close to 7. And that's why the name is neutralization reaction. The second class of double replacement reactions are precipitation reaction. What happens? If any of the products are in solid state, the product will be as a precipitate and the reaction will be called as a precipitation reaction. So here is our first example. Let's get started. Alright, these are our reactants and each compound has different cation and anion. So potassium is going to switch the partner and pair with fluorine, and tin is going to pair with nitrite. So the products will be, there you go. It'll be potassium fluoride and tin nitrite. Now, how about balancing? This is what we have, the number of atoms before we balance. And look at this. That is the balance reaction. Now let's find out if the reaction is redox or not. These are the charges for potassium before and afterwards, and also for tin before and afterwards. So what we notice is the charge on potassium remains +1. Same thing with tin, the charge remains same. If the charges remain same, that indicates that it is not a redox reaction. In order to answer the second part, we need to write down the states for the product. Potassium fluoride will be aqueous, whereas tin nitrite will be a solid. Remember, if one of the product is solid, that must be a precipitation reaction. Is it going to be a reaction with acid and base? No. However, the reaction is not a neutralization reaction. There is no acid and base reacting. Let's work on the next reaction. And this reaction is a little tricky. What is given to us are not the reactants. They are actually the products of the reaction. So let's put an arrow and write down the products on the right hand side. So there we go. We got calcium phosphate and aluminum bromide as our products. Now, in order for us to predict or find out the reactants, we need to make sure that we switch the partners. So calcium must be with bromine and aluminum must be with phosphate. What could be those reactants? There you go. It's calcium bromide and aluminum phosphate. The next step is balancing. So there you go. Those are the atoms for different elements for reactants and products. Now you can practically begin balancing with either of the element, but it works if you have an element one side even and other side odd number. So let's see if you can balance the reaction and check your answer. So did you get the answer correct? Next question. Okay. Will this reaction be a redox reaction? It is a double replacement reaction, and we saw earlier the charges remain same on both sides. So it will not be a redox reaction. How about the second part of the question? We got one of the product in solid state, so definitely it is a precipitation reaction. However, it is not a reaction between acid and base. I guess you guys already know how to write the reactions now. So work on the reactions and check your answers. So these are our reactants, and hydrogen is going to pair with hydroxide, whereas calcium is going to pair with chlorine. So what are the products? Calcium chloride and water, which is HOH. Now next part is balancing. That's the number of atoms on both sides. And that's the final balancing. Now will the reaction be a redox? It is a double replacement reaction. So you can say it will not be a redox reaction. Now is this reaction forming a precipitate? Look at the products. This is aqueous and this is liquid. So there is no solid product. So this is not going to be precipitate. Is this a reaction for neutralization? We have HCl reacting with calcium hydroxide. There is hydrogen and there is hydroxide, and they both combine to form water. So guess what? This is a reaction of neutralization. And here is our final reaction of double replacement. And these are our reactants. How about balancing it? There you go. That's a balanced reaction. Will this be a redox reaction? No, because it is a double replacement reaction. Then both the products which we got are aqueous and liquid. There is no solid product, so it will not be a reaction for precipitation. But we have hydrogen and hydroxide on both the reactants. That means it will be a reaction for neutralization. So guess what? You guys already learned about how to write single and double replacement reaction, how to balance them, how to predict if they are redox or not, and also classify them as precipitation reactions or the reactions for neutralization. I hope you guys enjoyed the video, and I'll see you in next video. Until then, bye bye.